So the first section we're going to do is 3.6 implicit differentiation. So we're just going to do the steps first and then just do a problem. So the first step is differentiate both sides with respect to x, and when you differentiate the y term, multiply by dy over dx or y prime. And then step 2, you solve for dy over dx, y prime, and then you get y prime alone on one side.
Okay, so we're going to start off with a pretty difficult problem because we're going to have to use product rule. But we all start the same. All the problems start the same. So what we're going to do is find the derivative of both sides with respect to x. So we're going to find the derivative of both sides with respect to x. So the first step is to find the derivative of sine x, which is cosine x. And since we're just finding the derivative of an x, you don't have to add a y prime because you're not finding the derivative of a y. And so the next step is the negative x squared y. And since it's being multiplied together, you're going to have to use a product rule. And since there's a y, you're going to have to add a y prime somewhere in the problem. And then, so we're going to have to use the product rule. So I'm just going to leave the negative sign out and then put a parentheses right here. And then I'm just going to jump over here because this is simpler first. So the y, since you're going to find the derivative of y, you have to put the y prime. So that's just going to be plus y prime, and then the derivative of 10x is just 10. Okay, so to start, we're going to use the product rule. And the first step in the product rule is you times the first, so that's just x squared, times the derivative of the second, which is y. So that just, the derivative of y is 1, but since you're finding the derivative of a y, you have to use y prime. And then you're gonna do plus g of x, which is just the y. And since you're only finding y and not the derivative of y, you don't have to add the y prime. And then you do times the derivative of the second, which is 2x. So I'm just gonna rewrite this to make it more condensed. So it is x squared y1 plus 2xy. So now we're gonna plug this in to the equation up here. So now we're gonna distribute this negative sign to this and this. So you get negative x squared y prime minus 2xy, and then plus y1, and then the cosine x is still here. Okay, so the next step is to get y prime on one side. So this one and this one can stay on this side, but the cosine x and the negative 2xy have to go to the other side. Okay, so now that we have y prime on one side, we want to get y prime like as a single term. So in order to do that, there's like a trick. So you just factor out the y prime. So now you have y prime on the outside. And so there's still a 1 in front of the y prime, so make sure you don't forget that. So now you're left with y prime equals negative x squared plus 1 equals 10 minus cosine x plus 2xy. So now our job is really easy because we can just divide out the negative x squared plus 1 and move it to the other side. So this one, negative x squared plus 1. Okay, so now that we've divided negative x squared plus 1 to the other side, we have y prime by itself. So that's our final answer. y1 equals 10 minus cosine x plus 2xy all over negative x squared plus 1. So that's how you do implicit differentiation.
So a higher derivative is basically just finding the derivative of your first problem and then using that answer to find another derivative. Okay, so the first step in this problem is quotient rule. So that's bottom times derivative of the top, which is negative 4, minus the top times the derivative of the bottom, which is 3, over the bottom squared. So the first step of this would be to distribute. So from this problem, we're going to get -4 minus 12u. And then the next one, since there's a negative right here, we're going to distribute it. So it'll be -1 plus 4u times 3. And from this, we get -3 plus 12u. So I'm just going to bring this down. So since there's a negative and a positive, we could cancel these out. And we get -7 over 1 plus 3u squared. So now that we found the derivative of this, we're going to do the derivative of this. So we don't want this on the bottom, so we're going to move it to the top, which gets us -7 times 1 plus 3u to the negative squared. And that equals -7u to the negative squared. And then we're going to bring the 2 down to come out with a 7. So that'll get us -14u to the -3. But we're going to put this in here now. So -14, 1 plus 3u to the -3. And now we have to take the derivative of u and multiply it, so that's times 3. Okay, so I realized in the first part I messed up and put -7 times -2 is -14, but it's actually +14. So anyways, that gets us 14 times 1 plus 3u to the -3 times 3. So now we can write that as f double prime of x equals 14 times 1 plus 3u -3 times 3. Okay, so we can combine these two to make 42 times 1 plus 3u to the -3. So we don't want this negative, so we could easily just move it to the bottom, which will get us 42 times 1 plus 3u to the third.
Okay, so next we're going to be doing 3.8 derivatives of logarithmic functions. And we have two formulas. We're usually going to be using this one because most of the time there's something attached to the x, but when something's not attached to the x, we use this one. But for right now, for the example, we'll be using this one. So we're going to be using this equation because there's just more things added onto this equation. Our u in this formula would be x squared plus x, and in the formula it also says to find the derivative of the u, which would be 2x plus 1. So now what we're gonna do is plug these two into this equation. So it would be so after this, as I said, we're gonna plug this in. So it would be 1 over x squared plus x times 2x plus 1. You could move this right here, which would be 2x plus 1 over x squared plus x. And you can't really factor anything out from here, so this would be your answer.